Hello, my mathematicians. Today we're going to be looking at lesson 9.4, which is all about line graphs. And again, we're using the interactive lesson to guide us through this. So our essential question is, how can you use a line graph to display and analyze real-world data?
Hey there! Sasha and I have been watching the traffic on Talbot Avenue. We are counting the number of cars that pass each hour. We noted the number of cars driving by each hour, starting with the hour leading to 3 o'clock and going to 8 o'clock. We'd love to create a line graph to display and analyze the data. What can we learn about the local traffic from a graph? Come on, let's find out.
Let's learn how to use a line graph to display and analyze real-world data. A line graph uses line segments to show how data changes over time. The series of numbers placed at fixed distances that label the graph are the graph's scale. The intervals, or difference between the values on the scale, should be equal. Graph the data. Use the graph to determine the times between which the greatest temperature change occurred. Use the related data pairs in the recorded temperatures table to complete the problem. Let's unlock this problem. First, show the related data pairs in the table as ordered pairs. Next, complete the line graph. For the vertical axis, choose a scale and an interval that are appropriate for the data and add a title. Based on the range of values within the recorded temperatures table, a scale from 50 to 62 with intervals of 2 can be used for the y-axis. To show that there is no temperature data recorded between 0 and 50, a break in the scale can be used between these two numbers. Choose a title for the y-axis that indicates what data the values within the scale represent. In this problem, the values are temperatures, so an appropriate title would be Temperature in Fahrenheit degrees. Choose a scale and an interval for the horizontal axis and add a title. The times of day within the recorded temperatures table can be used as the scale for the x-axis with an interval of 1 hour. Since the time of day is being used as the scale for the x-axis, an appropriate label would be time, AM. Now that a scale and an interval have been selected for each axis, plot each ordered pair. Each ordered pair represents a coordinate or location on the graph. The first number in an ordered pair indicates a location along the x-axis. The second number within an ordered pair indicates a location along the y-axis. For the first ordered pair, 1 o'clock is the location on the x-axis and 61 is the location on the y-axis from which you would plot the coordinate. At 2 o'clock, the temperature was 57 degrees. At 3 o'clock, the temperature was 56 degrees. At 4 o'clock, the temperature was 54 degrees. At 5 o'clock, the temperature was 55 degrees. At 6 o'clock, the temperature was 54 degrees. At 7 o'clock, the temperature was 56 degrees. You are ready to complete the graph. Let's connect the points with line segments. Use the completed line graph to answer the question. Between what hours did the greatest temperature change occur?
So in which spot do we have the biggest difference in the line? I'm going to say it's going to be right here.
The greatest temperature change occurred between 1 o'clock and 2 o'clock. In which 2 months did the least change in average temperature occur? Use the line graph to determine your answer.
So we need to look to see where's the smallest amount, and the smallest amount that goes up is between January and February.
Great job! The 2 months that had the least change in average temperature were January and February.
And that is our lesson for today. So again, I'm going to leave you with one question, and I would then ask you to rate your level of understanding using fists to 5.